Hey everyone, and welcome. Have you ever really thought about what happens in that tiny little sliver of time after you hit send? Well, today we're going to pull back the curtain on the internet and demystify one of the most amazing systems ever created.
I mean, it really does feel like magic, doesn't it? You type out a message, you tap a button, and boom, it just appears on a screen halfway across the globe. But how? How does that data actually get from your device all the way over to its final destination? To get our heads around it, we're going to follow a single message on its big adventure, right from the moment you create it all the way to where it's going. And this journey is going to take us through these little digital neighborhoods and across massive global superhighways.
Okay, so every big journey starts with a single step, right? And for our message, that journey starts small, right where you are. It all begins in your very own digital neighborhood, your local network. This is what we call a LAN, or a local area network. Now, you can think of this as your digital driveway. It's that private little network connecting your computer, your phone, maybe your smart TV, usually all through your Wi-Fi router. Every single message has to pull out of this driveway first before it can even think about hitting the open road.
All right, now let's zoom out, way out. Once our message leaves your cozy little local network, it needs to get onto something much, much bigger. So, welcome to the global superhighway. So if your LAN is the driveway, a WAN, or a wide area network, is kind of like the city streets and the big state highways. Its job is to connect a whole bunch of those local networks together, but across huge geographic areas. This is the first major jump in scale for our little message.
And what happens when you connect all of those LANs and WANs together? Well, you get the internet. You see, it's not just one single thing. It's actually this massive, sprawling, interconnected system of millions and millions of smaller networks, all just agreeing to talk to each other using the same language. This is the true global superhighway. So how do we actually get on to this superhighway? Well, there are a bunch of different on-ramps. You've got cable, DSL, your phone's cellular connection, even satellite. These are all just different ways to merge into that main flow of internet traffic.
Now, you'd think that with billions of messages zipping around this global highway system all at once, it would be total chaos. But it's not. It all works incredibly smoothly. And why is that? Well, it's because everybody and every device follows the same set of rules.
In the world of networking, we call these rules protocols. And really, a protocol is just a shared language. It's the thing that makes sure a computer in Brazil can perfectly understand what a server in Japan is saying, even if they were made by totally different companies and run completely different software. And what I love about this is how you can think of these protocols as having specific jobs, you know? The Internet Protocol, or IP, that's like the postal service. Its whole job is to slap an address on every single message. Then you have TCP, who is like this super reliable proofreader, checking to make sure the entire message gets there without a single error. And DNS? Oh, DNS is the Internet's contact list, turning those easy-to-remember names like Google.com into the numerical IP addresses that computers actually need. Okay, so we know the highways, and we know the rules of the road. But our message, well, it isn't quite ready to travel just yet. First, it needs to get dressed for the journey. See, your message can't travel as one big chunk. The first thing that happens is it gets translated into binary code. That's the encoding part. Then, that digital data gets broken down into these tiny, manageable pieces called packets. It's kind of like taking a giant encyclopedia and sending it one page at a time. Each little packet is a small piece of the whole, and it's ready to make its own journey. So let's just walk through this real quick. Step 1, creation and encoding. That's your message turning into digital code and breaking into packets. Step 2, formatting and encapsulation. This is where each of those little packets gets wrapped up with all the addressing info. Step 3 is transmission prep, just getting it ready to be sent. Step 4 is, of course, the journey itself. And finally, Step 5, arrival and decoding, where all the packets are received, put back in the right order, and turned back into your original message. And this is a perfect illustration of that wrapping process we just talked about, encapsulation. It's brilliant. Each packet of your message gets put into a digital envelope, and then that envelope gets put into another one. Each layer adds a new set of instructions for a different part of the trip, like the TCP info for making sure it's all there, and of course the IP address for the final destination. So our message is encoded, it's addressed, it's all sealed up in its digital envelopes. It is finally ready to go. But who exactly are we sending it to? Well, the network actually has a few different ways to handle that. So the network can deliver a message in 3 main ways. A unicast message is a private one-to-one delivery, just like a direct message. A multicast is one-to-many, which is perfect for sending something to a specific group, like all the players in an online game. And a broadcast is a one-to-all announcement, sent out to every single device on a local network. So, when you put all of that together, the local networks, the global highways, all the strict rules, the careful packaging of every single little packet, you get this: an invisible, unbelievably complex, but somehow beautifully orderly system that we rely on for, well, pretty much everything. It's just this constant, high-speed dance of data happening all around us all the time.
The next time you click a link or send an email, just take a second to think about that message's incredible journey. Are you going to think about the protocols, those rules of the road that keep everything in order? Or maybe the billions of tiny packets being wrapped up, sent across the world, and then perfectly reassembled on the other side? It's a hidden world that makes our modern one possible. Pretty amazing, right?